Calculus, rate of change. Slopes and rate of change is chapter 1 for us in calculus. It really gets into the concepts of calculus. Calculus is all about finding slopes and slopes of different kinds of curves, right? So let's understand some basic things which we'll need a lot while working out calculus problems, right? Here is one expression which says 3 plus h to the power of 4 minus 81 divided by h. So we should know how to simplify this kind of an expression. Now here we know difference of square formula, we can use that. Or to expand this a plus b to the power of n, we could use Pascal's triangle. So the idea of having this question here is to remind you that you already know many things which you can apply here in calculus, correct? So you know factoring. Factoring skills can be applied here to solve, or you know Pascal's triangle, which can be used. So when this power is like even 4, factoring is much shorter and better way. But imagine if this was 7, 9 or something like that, Pascal's triangle would have been a better option, correct? So let's solve this by factoring. So we can write this as difference of squares, right? Think like this. 3 plus h whole square and this is 9 square. So now it becomes difference of square. Do you see what I'm trying to say? A square minus b square. So we can factor this and then write down a plus b times a minus b. So a for us is, let me write this in the bracket, a for us is 3 plus h whole square, right? Plus b, and b is 9 for us, times 3 plus h whole square minus 9, correct? So that becomes our numerator and the denominator remain as h. Now, let's expand this. If we expand this, we get a plus b whole square. That means a square plus 2ab plus b square. And so we get here 9 plus 2 times 3 is 6h plus h square plus 9 we have. That's the first factor. The other one will be, well, that part remains same, 9 plus 6h plus h square minus 9, and the denominator for h. Now we can further write it down as, now 9 plus 9 is 18, right? So it is 6h. Now let's order that in terms of h square, right? So we get h square plus 6h plus 18 times 9 minus 9 is 0. So we get h square plus 6h over h. That's what we get. Now from here we can take h common and further simplify. So let me take it on the right side. So this could be written as, so I'm taking h common here, right? So when I take h common, I get h here, and then I have h square plus 6h plus 18 times h plus 6 over h. You see that? And now we can cross out h divided by h is 1. And so we get the term h square plus 6h plus 18 times h plus 6. So that is the simplified form of the given expression, right? So that is how you're going to do it. Now, if you were trying to do it with Pascal's triangle, how will you do? Now, in that case, what you could do is you could expand 3 plus h to the power of 4, and then you can solve the numerator, right? And then you'll get your expression, which will help you to find the right answer. Now, in that case, now still we need to expand this and write it down, correct? But factorial form is good enough. I'll just stop here to show you that how you could use Pascal's triangle, correct? So let's start with Pascal's triangle. So let's start with 1, right? And then when we go down, that is to the power of 1, a plus b to the power of 1. And then we get this, where, let me write numbers in a different ink. It's getting mixed up, so it's like 1, 2, and 1, right? And then the next level, where, how do you write these numbers? You add the previous two. So 1 plus 2 is 3, 2 plus 1 is 3, and this is 1, right? So on the edges, you'll keep on getting ones, right? So it's kind of overlap, that's fine. So we get here 1, 3 plus 1 is 4, 3 plus 3 is 6, and 3 plus 1 is 4, and that is 1 for you. So with this expansion, we get 1, 4, 6, 4, and 1. Now we can use this expansion here to expand 3 plus h to the power of 4. And now let me expand this and write it down for you here in this limited space, right? Now 3, so how will it come? So these are a's and b's, and these are the coefficients, right? So first number is to the power of 4, correct? So 3 to the power of 4, that's the first number, 3 to the power of 4, right? The next number is, coefficient is 4, so we say plus 4, and now we'll do 3 cube times 3 to the power of 3 times h, correct? Next number is 6, so we'll write plus 6, and 3 to the power of 2. The powers of the first number decreases from 4 to 0, and for the next number increases from 0 to 4. That's the whole thing. So here it becomes 2. So sum of their powers will always be 4. Remember that. Plus, next coefficient is 4. So we write 4 times, let me write these dots in between, reminding you that's not 43, it's 4 times 3 to the power of 1 and h to the power of 3, right? And the last number for us will be plus h to the power of 4, correct? Minus 81 was this thing, divided by h. And now we can simplify this, correct? Now, 3 to the power of 4 is 81. So that becomes 0, right? So we are left with 4 times 3 cube. 3 cube is 27, right? So 4 times 27. So we can expand this and write 4 times 27, which gives us 108. So I'm multiplying this and I'm writing 108 h. And here 3 square is 9. 9 times 6 is 54. 54 h square. 4 times 3 is 12. So 12 h cube plus h to the power of 4, everything divided by h. And now you will see that h and h will cancel. So we are going to get our answer as 108. So we are taking away h, dividing every term by h. So we get plus 54 h plus 12 h square plus h cube. So that becomes our answer. So using Pascal's triangle, we could have done it right away like this. And now using factoring technique, we came up to this place, and we'll get this answer if we multiply these components, right? So when you expand this factor, you will get your answer. That is how you're going to get it, right? So the answer will be same. So you need to, if you want answer in factored form, that was better approach. But if you want it more simplified, then this is the approach, correct? But anyway, the idea here is to expose you or to remind you of the two techniques which you already know and can be applied. So in calculus, all these techniques are going to be of great help to you. Thanks, and I hope you appreciate. All the best.